Hello friends, let's have a look at today's daily challenge problem. Problem 1475, final prices with a special discount in a shop. So basically, we are given an array. So we want to find the next smaller or equal element and then use the current element minus that element. So let's look at the example. For example, example 1, for 8, the next smaller one is 4, right? So 8 minus 4, you're going to get 4. Well, for the number 4, so the next smaller or equal one is 2. So 4 minus 2, you are going to get 2. And for 6, the next smaller one is 2. So you get 6 minus 2, that is 4. Well, for 2, so there's no smaller ones coming up, so we're going to remain 2 here. And for 3, because it's the last element, for sure, there's no follow-up smaller or equal element, so we get 3 here. So in example 2, because this is actually a strictly increasing one, there's no smaller ones for each element to its right, so it just return itself. So similarly, you can look at example 3. So for 10, you have a 1 follow-up, so 10 minus 1, that is none. So for the first one, you get a 1 followed, so 1 minus 1, you get a 0. Then from the next one to 6, actually is monotonically increasing, so you just remain 1 and 6. So that's the full problem. So here actually the price's length is very small. It's bounded above by 500. So it's actually really a very simple problem. Even I think you can just do some brute force and search for each index. But here what we want to explain is a technique called monotonic stack. So this problem 1475 can be regarded as a prototype problem for monotonic stack. So actually, if you look at problem 739, daily temperatures, you can also use this one as a prototype problem. In other words, it's very simple, but it demonstrates the use of monotonic stack. So for this problem, obviously for each index I, we want to find the first index G to its right, such that the prices at index G is no larger than the prices at index I. Then we just need to adjust the price at index I to be the price at index I minus the price at index G. So this order relation always make the final return element will be non-negative, right? So that's the main logic. So now let's do the coding. And I'm going to code 2 versions, essentially 1 version. The first version I'm going to write with some details. And then in the second version, I want to write a compact one. With that said, I changed the prices to be capital P just for the ease of typing. First, I get the length of this list. It's just for convenience. So first, I want to find this piece of the information. For each index, I want to find the right index G if there are, right? Such that this relation holds. If no such G exists, I'm going to maintain that to be say -1. So I'll call this information. So I'm going to initialize each element using -1. And then I'm going to initialize a stack, right? So this stack actually will be locally monotonic increasing, right? So you can imagine, so in this stack, we are going to store the indices, right? So for this example 2 here, you can imagine the final state will be 0, 1, 2, 3, 4, right? So what we are going to do is we do a for loop for I, Y in enumerate P, right? Then we're going to check the stack, right? So while stack, and then we check the top element at the stack, that is stack -1, because we have read this condition before. So then this is legitimate to call stack -1, right? Then we consider the element at this index. So if it's less than or equal to the Y, it means for the current index I, it's the rightmost, the first right index corresponding to this index at the top of stack, such that this relation holds, right? So we can first get the previous index. Let's see, that's the stack pop, right? So this pre corresponds to here, right? Called this element. So because this one is less than or equal to the current value at index I. So index I plays the role of index j here, right? Previous will play the role of I. Then what we want to do, so we want to set info at this index. The follow-up index with this relation will be I, right? So then after we exit this while loop, there are two possibilities. First, the stack is empty. Otherwise, so the top element at the stack will correspond to a larger element, and that is y, right? So then what we want to do, so we can stack append this I, because we want to also get this information. We want to find the current I for this current index I. What's the follow-up index that can make this happen, right? So you notice that because of this assignment, so if no such index, so then this corresponding position will still maintain a 1. So that's the information. Now let's print out this information. So so for this one, so for this one, so the next larger I guess let's see here. Let's see. I actually reversed this direction. So here's greater than or equal to, right? Because y should be smaller. So let's run it again. Yeah, for this, because this one is a monotonically increasing array. So no follow-up index with smaller elements. So all is -1 here. And then let's try this one, right? We know for index 0, it should be corresponding to 1, right? Index 0 is 1. For index 1, that is a 4. The value is 4, corresponding to this one, index 3. So index 1 gives index 3. So for the index 2, that is 6, the smaller one is 2. It's also corresponding to 3. But for 2 and 3, so no follow-up smaller elements. So we have -1, -1. So similarly, you can look at this one. Let's do it slowly so that you can have time to digest, so, right? Like reasoning, you think several minutes, seconds, right? So 10, and so the next index will be 1. So we have 1 here. 1, the next index will be 2. For 1 and 6, and then they have no follow-up smaller ones. So they have -1, -1. So we get all this informations. Now that we get this information, actually do the return is rather straightforward. So let's see. We can call p copy, right? So if the index corresponds to value that is -1, we don't change the value. So that's why it's convenient to use a copy. So for I and idx in enumerate info. And then what we want to do is to set result I equals result I minus not result I, so pi minus p idx if idx is not a -1. So I guess the otherwise it's just the result. Otherwise it's just the pi, right? If we write like this, or we can do something like this. If idx does not equal to -1, then we do this. So what we want to return is the final state of this result array. Let's do a quick check. Yeah, it passes the last example 3. Let's also try this one. So it passes the first example. Now let's look at an extreme case. That is example 2. So you get this one. So, and also if you want, for after each I, you can also print out the stack state. So stack state before I, right? So you get stack, and also you can print this one after exiting this one, right? So let's for this one. This is very special because you are going to have 1, 2, 0, 1, 2, 3, and 4. Let's run that, right? Before it's empty, then after you get index 0, and then you get 0, 1, and then you get 0, 1, 2, and then you get 0, 1, 2, 3, 4. So in other words, the index, the stack, if you consider the corresponding element, is corresponding to a monotonic increasing element value. So if you look at this one, so first, for index 0, for sure, you get this one. It's very easy to understand because originally it's empty. Then I look at 4. Because 8 is larger than 4, I need to pop it up. Because for 8, I already get the first red smaller, the index corresponding to a smaller or equal value. So then you're going to pop that 0. And then after you exit 4, you should add the index 1. That's the state. And then for 6, because 6 and 4 is increasing, so I'm going to have this one because it's a locally increasing stack corresponding to increasing values. So now if I look at the number 2, right? So because 6 is greater than 2, I need to pop that, right? And then so it's before 3, so we have 1, 2. And after 3, because we get this one popped, we add the current index, you get 3. So then, because this is again corresponding to the index corresponding, this is the monotonic increasing, so we get the corresponding indices, right? 3 and 4. So also this is the return. So you can also see this one. So now if you print out, you analyze this, you will have a very vision experience, but it's also good to reasoning or think abstract in the abstract way. Right, so this is the stage. Yeah, it's very easy to understand. So now I guess with this examples and walkthroughs, so we should have a good understanding on how to solve this problem. But here I guess this code is a little bit too detailed, right? So what I'm going to do is to copy this part. And then I'll change this one to be version v1 because it's too detailed. This is for digestion, right? So now what I'm going to do is I don't need this one actually. And what I want to do, I want to directly have a result equals p copy. In the while loop, I'm going to modify the this array. So here, let's comment this out. You can see this is the skeleton of the code instructor, right? Code structure. So here, even I don't need this n, right? So then we have this result. This is what we want to return. Then we have a stack to store the indices to maintain a locally increasing stack. So here increasing is the corresponds list values, right? This should be realized. Then for I, y in enumerate. So here we use enumerate because we need to retrieve the indices. So well, this is true, right? We get this one. Then we don't set this information. But what we want to do is result previous minus equals previous result. Let's see. We can use p, for example. P I. This is the y, right? So that's actually it, right? So then we append that. Let's do a test. Yeah, it passes the last example. Now to make sure, I'll also test the first example. Yeah, it passes the first example. Now general case. Yeah, it's very fast, I would say. With that said, I guess that's basically about it for the coding part. So let me make a quick summary. So first, here the monotonic stack is a very common technique. And the reason we present this daily challenge problem or this easy problem, so is that we want to prototype this problem. You can use this one as a prototype for applying monotonic stack or practice monotonic stack, or you can use this problem. So you are welcome to check the video for problem 779 or try to solve the problem by yourself, and then do some similar problems to make yourself familiar with this technique. With that said, I guess that's it for the current video. Thank you for watching.